All right. Hello and welcome everybody to another physics video lecture. Today we are talking about explosions. It's an exciting day. All right. So again, to understand what an explosion is, we need to go back to this concept of momentum. All right. All right. Momentum is mass in motion. All right. And from this definition, we get its equation, which we've seen a bunch. Okay, momentum is P, and it is equal to mass times its velocity, or its motion. The bigger the mass, the more momentum. The bigger the velocity, or the faster the velocity, the more momentum. Okay, we need to understand this concept of momentum. Okay, how difficult it would be to stop an object because of this law, the law of conservation of momentum. This is how we understand all collisions and explosions, okay? And it tells us that momentum is always conserved, okay? Being conserved means that something is saved. So that means that the momentum we have before the collision, or in this case explosion, equals the momentum after the explosion or collision, okay? Momentum is always conserved. Now, in the past, we have seen our first two types of collisions. We saw elastic collisions. This is where the objects bounce off of each other. Now, since they bounce, that means that the objects start off separate from each other, so they each have their own momentum, and they bounce, so they end separate from each other. They each have their own momentum, okay? The example here would be pool balls, or if you've ever seen these Newton balls, a baseball, hitting a baseball bat, you kicking a soccer ball. Anytime two things come into contact and bounce off of each other, that is an elastic collision. They are special because not only is momentum conserved, but kinetic energy is conserved as well. The second type of collision we saw is an inelastic collision. Now this IN, this prefix means not, like if something is incorrect, it's not correct. In this case, if something is inelastic, if a collision is inelastic, it's not elastic, meaning that the two objects do not bounce, they stick together, which means that the two objects are going to start off separate, meaning that the first object has its own momentum and the second object has its own momentum, but when they hit each other, they stick, which means now the two objects are combined and you add their masses together and they only have one velocity, because they're only one object, okay? And again, momentum is always conserved, and it's the only thing that's conserved. And here, the examples you'll see are like car crashes. Sometimes you'll see things where two balls of Play-Doh come together, somebody jumping into an inner tube, somebody running and jumping on somebody's back, two football players tackling each other. These are all examples of inelastic collisions. The objects start off separate and stick together. Now today, we're looking at the third type. These are called explosions. Okay, here the objects start together, but they end separate. All right, that is the definition of an explosion. Now, when we look here, okay, a great example would be a gun and a bullet, or a cannon and a cannonball. Okay, an explosion means that something starts off as a whole and ends up separate. So here, now, we see that the momentum before the collision, everything's together, right? Before it explodes, the cannonball is inside the cannon. The bullet is inside the gun. So we take their two masses, we add them up, and because they're only one thing, they only have one initial velocity. After the explosion, those two objects are now separate, right? Wait for it. There it goes. Now they're separate. So now each object, the cannon and the cannonball, have separate momentums. So each one has a mass times a velocity and a mass times a velocity. All right? So we're going to look now, again, as with all of these, this is what you need to know about explosions. They are together before the collision, okay? Which means that you add their masses and multiply it by just one velocity. And they're separate after the collision, or I should put explosion, but they're really the same thing. An explosion is a type of collision, which means that the first object has its own mass and final velocity, and you add that to the momentum of the second object, which has its own mass and final velocity. They start off stuck together, they end up separate. The momentum before the collision always equals the momentum after the collision. That is the law of conservation of momentum. All right, here are what all the variables mean. If you did not follow there, I always included. M1 plus M2 is the two masses combined. V1 is the initial velocity of, oh no, I put both objects. Oh yeah, both objects, sorry. That is correct. Both objects are stuck together, so which means they have the same velocity, right? M1 is the mass of the first object. M2, the mass of the two, there, that's where I made a mistake. M2 is the mass of the second object. I will fix this before I post it for you guys. V1F is the final velocity of the first object, and V2F is the final velocity of the second object. So let's jump in and do a couple practice problems, all right? Practice problem number one. We love, when we talk about explosions, to talk about cannons and cannonballs, so let's dive right in. Step number one, write down everything that you know and make a chart. We have a 750 kilogram cannon, so that is our mass one. Mass one, 750 kilograms. That holds a 16 kilogram cannonball. It's a big old cannonball right there. We're gonna call that mass 2, 16 kilograms. The cannonball is fired at 120 meters per second. All right, so we said the cannon was 1 and the cannonball is 2, so we know that the final velocity of the cannonball is 120 meters per second. I will stop here just so everybody gets this. Mass 1 is the cannon, right? On this one. And mass 2 is the cannonball. All right? So the cannonball is fired at 120 meters per second. That means that after the explosion, the final velocity of the second object, the cannonball, is 120 meters per second. How fast and in what direction does the cannon move after the explosion? So we're looking for the after, we're looking for the final, we're looking for V1F. So question mark, V1F. Now, we're missing one thing. We're missing the initial velocity of the cannon and the cannonball. Well, if you've ever seen a cannon, they just sit there. So what's their initial velocity? Oh, our VI is 0, which as you will see makes these pretty easy to solve. All right? Write down our equation. The two objects start off together. So we have M1 plus M2 times V initial. The cannon has the cannonball inside of it. They're together. They only have one velocity. And then they explode. So we have M1 V1F plus M2 times V2F. Boom. There's our equation. We just plug in our numbers. M1 is 750 plus M2 is 16 times V1I, which is 0. That equals, that's 750 times its final velocity, which is what we're looking for, V1F, plus M2, which is 16 times its final velocity, which is 120. Now, the first step you always got to do is just your regular old math. And here is why I like these. 750 plus 16 is 766. But guess what? You're multiplying it by 0. And 766, like any number times 0, gives me a big old goose egg, which is 0. Let me write that again. 0. 0. So this whole side of the equation is 0. Isn't that nice? Here we have 750 times V1F, and we're going to add that to 16 times 120, which we are going to bust out the old calculator for, make sure I got it. All right, so we got, what did I say, 16 times 120, and that is going to be enter answer 1,920. All right, now our goal here is to get V1F by itself. In order to do that, we have to move both of these numbers, right? Now, this is multiplication and this is addition. Whenever you're reversing this, you have to do PEMDAS backwards, which means that you gotta move the addition and subtraction before you mess with multiplication and division, all right? It's just a rule of algebra. So the first thing we're gonna do is we're gonna subtract 1,920 from both sides. That gives me negative 1,920 is equal to 750 times V1F. Anything minus itself is 0. Boom, boom. And now hopefully you guys can see this. We have a very familiar looking equation. I want V1F by itself. This is multiplication. I do the opposite of multiplying and divide by the number I want to move, which is 750. Whatever I do to that side, I got to do to this side. 750 divided by 750 is 1. That cancels out. I go back to my calculator. 1920 divided by 750 gives me 2.56. Or, to be more specific here, it is going, see this negative right here? This is going to give me V1F is negative 2.56 meters per second. That's our answer. Now, in the question, I said how fast and in what direction? Well, I know that it's going 2.56 meters per second, but I wanted to know what direction. And to find direction, we got to see if it's positive or negative. This one is negative, okay? So if it fires the cannonball, let's say the cannonball is going to the right, okay? Well, the cannonball's velocity was positive. That means which way is the cannon going to go? It's going to go backwards, right? This is Texas. Maybe you've shot a gun before, but whenever you shoot something, when it goes forward, for every action, there's an equal and opposite reaction. So if the cannonball goes forward, the cannon is going to get pushed backwards. It's called recoil. So the cannon goes to the cannonball goes to the right, it's positive. Cannon goes to the left and is negative. All right, pretty straightforward there. All right, let me grab a new marker. Let me get a freshie because I'm doing a lot of writing here. All right. Good. Okay. Let's do number 2. Okay. So here, now we're talking about a gun. Okay. Same old same. Write down what we know first. All right. Number 1, we have a 3 kilogram gun. That is my M1. It's 3 kilograms. It's the mass. It holds a bullet of 0.002 kilograms. If the gun recoils at 0.4 meters per second to the right, okay? In fact, just so that this matches what you're seeing on the screen, watch this in real time. If the gun recoils at 0.4 meter seconds to the left, right? So the gun, when you fire it, the gun is going to go to the left. How fast and in what direction does the bullet fly? Well, we already know what direction the bullet's going to fly, right? The gun's going to go this way, the bullet's going to go that way. And just to keep with what we've seen before, let's say that right is positive and left is negative. I like that personally. So we know the gun starts off stationary, which means its initial velocity is 0. Isn't that nice? The gun's not moving. I didn't write that here because this is already really long and I need a lot of space, but the gun is stationary. If I know that the final velocity of the gun, V1F is equal to negative 0.4 meters per second. Sorry guys, I think I might have had too much coffee today. The gun goes 0.4 meters per second to the left, going this way. We're calling that negative. So this is negative 0.4 meters per second. What is the final velocity of the bullet? Same as the last one. The two objects start off together. M1 plus M2 times V initial equals, I don't need this parentheses here. It's implied V1F, M2 V2F. I plug my numbers in, okay? This will be 3 plus 0.002 times 0 equals 3 times negative 4 plus 0.002 times V2F. Same as the last time, I add these up, I get 3.002, but you're multiplying it by 0. Anything times 0 is 0. So I have 0 equals 3 times negative 4, gives me negative 12 plus 0.002 times V2F. V1F. See how I just did the math and brought that down? Now, again, I want this V2F by itself. So I got to move these two numbers. You always do addition and subtraction first and then mess with multiplication and division second. Sorry, addition and subtraction first, okay? I want to move negative 12. Since it's negative, I got to do the opposite, which is adding it. So I'm going to add 12 to both sides. I'll do that in purple so you can see it. Whatever I do to this side, I have to do to this side. Negative 12 plus 12 is 0. And 0 plus 12 is 12. Pull that 0 down. This gives me 0.002 times V2 final. And we are back to very familiar territory here. I want to get V2F by itself. This is multiplication, so I divide by 0.002. Whatever I do to that side, I got to do to this side. And I bring in my calculator. There it is. Let me clear all this up. Sorry, I've got a big glare going here. And I got 12 divided by 0.002. Enter, and my answer gives me 6,000. Oh, shoot. Mr. Norris, you did something wrong. Do you know what I did wrong, guys? Look at this. Look at my speed. My speed was 0.04. This was not 4. This was 0.4. Were you saying that to me the whole time? If you were, good job. Which means that this is not 12. This is negative 1.2. Which means that this is not 12. This is negative 1.2. Which means that this is not 12. This is negative 1.2. And when we do that, we don't get 6,000. We get a final velocity of 600. Look at those little mistakes. Even I make them, okay? If I'm trying to rush, right? So here we had negative 0.4, not 4. So 3 times negative 0.4 gives me negative 1.2, which means I had to add 1.2 to both sides. These canceled out, and 0 plus 1.2 gave me a positive 1.2. Did you get the right answer? Did you get 600? Going to the right. Was it positive? It should have been positive. All right, guys. Let's do one more. And I'll try to make 0 mistakes this time around. Hopefully you got that one. All right. We got 2 astronauts, Mary and Harry. We're going to say Harry's number 1. It's alphabetical. M1 is equal to 80 kilograms. Mary is 2. She weighs 60 kilograms. They're holding on to each other and moving 2 meters per second to the right. That means they have an initial velocity, and that is going to be 2 meters per second. It's positive because both of them together are going to the right. They're stuck together. They're moving this way at 2 meters per second. Harry pushes Mary, so she is now moving 5 meters per second to the right. So we know that the final velocity of Mary is 5 meters per second to the right, which is that way, which is the same as this direction. We're saying right is positive, left is negative, right? This way is positive, this way is negative. How fast is Harry moving? All right, V1 final is what we're looking for. So, little different, same setup. M1 plus M2 times V initial equals M1 V1F plus M2 V2F. They start off together, they're holding each other, and now they end up separate, going in opposite directions. So we know that their velocities are going to be going in opposite directions. One will be positive, which we already know is Mary is positive. So we know Harry is going to be negative. It's just something you know right off the bat in all of these equations and explosions. So we add them together, plug the numbers in. 80 plus 60 times 2. Double check all my numbers are right. Good. He's 80 kilograms times V1F. That's what we're looking for. She is 60 kilograms and is moving 5 meters per second, which is positive because she's moving to the right. Do the math. 80 plus 60 is 140. 140 times 2 gives me 280. This gives me 80 times V1 final plus 60 times 5, which gives me 300. Okay? So now this is, trust me on that one. So what we're going to do, we want V1F by itself. So I got to move the 300 first because it's being added. So I'm going to subtract 300 from this side. 280 minus 300. Well, first of all, 300 minus 300 is 0. 280 minus 300 is negative 20. And then I bring this down, which is 80 times V1F. Now, same old thing. V1F is what we want. This is being multiplied, so we divide by the 80. 80 divided by 80 gives me 1. And going back to our calculator, clearing everything out, this gives me negative 20 divided by 80. And negative 20 divided by 80 gives me negative 0.25. Negative 0.25 meters per second. And there's your answer right there. Okay? Again, when they push, she ends up moving really fast, which means he has to move really slow. Okay? It's just the nature of the beast. He must have pushed her really hard. Okay? And remember, they start off separate, or they start off together. They end up separate here. She's going to the right, which we said is positive, right? So he's got to be going to the left, which means his velocity will be negative. All right, guys, I know that these equations take some time, but if you go back, if you look at the equations, if you plug in the problems and work through these, I guarantee you're going to do great. Email me or find me at tutoring if you have any questions. Other than that, have a beautiful day.